Good morning, good evening, and thank you all for joining this session. From hallucination to accuracy. I'm Jasleen, a senior principal research scientist at Dell Technologies based in Austin, Texas, where I focus on applied generative AI. As generative AI continues to evolve, retrieval-augmented generation or RAG has emerged as a go-to approach across industries. It's being widely adopted to help large language models generate responses grounded in up to date and domain specific information. But even with RAG, we still encounter incorrect responses, or as we say in the world of generative AI, hallucinations. And more often than not, we blame the large language model. However, the truth is, hallucinations in RAG often stem from how we retrieve and present information to the large language model, not just from the model itself. In today's session, I'll dive into these overlooked aspects of the RAG pipeline, those hidden culprits behind inaccurate answers, and I'll explore how we can move from hallucination to accuracy. Let's walk through how RAG or retrieval augmented generation actually works step by step. It all starts with preparing the data. Raw data is first cleaned and broken down into manageable chunks. These chunks are then converted into embeddings, which is essentially numerical representations that capture the semantic meaning of the text. These embeddings are stored in a vector database. Now, this is different from a traditional database. A traditional database stores structured data. Think rows and columns, and it supports exact match searches. In contrast, a vector database is built for unstructured data. It stores high dimensional embeddings and allows for similarity based search, which is key when working with language data. Now, when a user asks a question, say, how do I resolve out of memory issues? This query is also converted into an embedding and it's sent to a vector database. The system then retrieves the most relevant chunks of information, which is often referred to as context, that helps the large language model formulate a response. These retrieved chunks are combined with the original user query to form a single prompt, which is then passed on to the large language model or the LLM. Now, the LLM here uses both its internal knowledge and this external context to generate a response. But here's the catch. The quality of that response is highly dependent on the quality of the retrieved context. If the context is irrelevant or poorly matched, the LLM's answer is likely to be inaccurate, or what we call hallucination. In other words, garbage in, garbage out. That's why RAG is so important. It allows LLMs to access fresh, domain specific knowledge without the need of constant retraining. But the retrieval step is absolutely critical. It's like the gatekeeper of quality. If we get that wrong, then everything downstream suffers. In summary, RAG enhances LLM's capabilities by allowing them to stay accurate and up to date, even as information changes, while avoiding the high cost of complexity of frequent model retraining. Now let's understand what the issue is and what do we mean by hallucination and why does it have such a huge impact. Now, in an ideal RAG pipeline, a query comes in. Based on that query, relevant context is retrieved, typically using semantic similarity between the query embedding and the vector embedding of the documents. The retrieved context is then appended to the query and passed to the LLM to generate the response. Now, here's where things get tricky. The quality of the retrieved context determines the quality of the answer. But RAG does not always get the right context. Imagine asking a question about company revenue trends, but the retrieved context talks about headcount or product launches. The LLM will still try to answer because that's what it's trained to do, even if the context is incomplete irrelevant, or missing altogether. And this leads to hallucination, where the model generates a confident sounding answer that's either incorrect or grounded in the incorrect context. And this isn't just a minor bug. In many use cases like healthcare or legal or finance, hallucination is a serious risk. It erodes trust, it misleads users, and can cause real harm. But what's the core of the problem? Garbage in, garbage out. If the retrieval step pulls in the wrong data, the LLM cannot magically fix it. In fact, it often makes things worse by filling in the gaps with plausible sounding but made up content. That's why understanding and improving context retrieval is absolutely critical because everything downstream depends on it. Let's break down the key reasons why hallucinations happen in RAG systems. The first is irrelevant or noisy context. Sometimes the retriever pulls in content that's semantically similar but contextually useless. For example, if someone asks about cloud billing best practices, and the retriever fetches content about cloud weather predictions. Now, the semantic match here may be high, but the information is completely irrelevant. This kind of noise confuses the LLM, and it often leads to plausible sounding responses but grounded in the right fact. The second one is missing context. Now, on the flip side, we might fail to retrieve critical pieces of information that are needed to answer the query. This happens when the query and the relevant content don't align closely enough in the embedding space. And this may happen due to how the data was chunked, poor vector quality, or the retriever's limitations. Now, the LLM, lacking the right facts, ends up filling in the blanks, which is just another form of hallucination. The third one is LLM overconfidence. Even when the context is weak or missing, the LLM will still generate a response, and often it will sound very confident. This is a fundamental behavior of large language models. They are designed to be fluent and coherent, but not always accurate. So, even when the underlying context is shaky, the output can seem polished and trustworthy, which makes hallucinations even harder to detect. The fourth one is outdated or inconsistent sources. Now, in some cases, hallucination is not caused by retrieval quality alone, but by the quality of the sources. If the retrieved documents are outdated, contradictory, or just wrong, the LLM is building on a faulty foundation. It might blend multiple perspectives into one average answer or pick the wrong one entirely, especially when it cannot resolve conflicts in the data. So, hallucinations isn't just about the LLM making things up. It's often a symptom of retrieval issues, embedding mismatches, or data quality problems. Fixing the problem of hallucination requires us to look deeper into the entire RAG pipeline and not just the generation step. Now, let's talk about evaluation and why the way we currently evaluate RAG system is quite frankly broken. Most of today's evaluation methods are LLM centric. They focus on the final output. They measure things like fluency, grammar, coherence, maybe some light factual consistency, but often metrics like Blue, Rouge, or even GPT based scoring. Now, these methods tell us how good the answer sounds, not whether it's actually grounded in the right context. And here's the big problem: they only evaluate hallucinations after it's already happened. It's like checking the temperature after the fire has started. But hallucinations in RAG often stem from the retrieval step, and that's where evaluation efforts are lacking. So, what's missing here is context evaluation. There is no standardized way to score the quality of the retrieved chunks. We don't ask questions like, Was this context relevant to the question? Was it complete? Was it current? Or was it outdated, off topic? Or was it just noise? And as a result of that, irrelevant or partial context often slips through undetected, and we only notice it after the LLM generates a problematic response. But by then, it's really too late. If we want to build trustworthy RAG systems, we need to shift our focus earlier in the pipeline. We need to build tools and frameworks to evaluate and improve context quality, not just the final output. Now that we've seen how broken the current evaluation process is, how it often relies on post hoc metrics or hand labeled outputs that don't scale and don't always reflect the real user experience, let's talk about a better way, a more proactive approach, one that doesn't just test the system after its decision has been made, but that guides the decision in real time. And this is where agentic AI comes into play. Now, instead of simply relying on the large language model to do all the work, we introduce an intelligent agent that evaluates the context before the LLM ever gets a chance to generate a response. Let me walk you through how this process looks. Imagine a query comes in, just like it would in a typical RAG pipeline. The first step is quite familiar here. We run a similarity search across our vector database and retrieve the top n chunks based upon embedding similarity. But here's where things start to get interesting. Instead of blindly passing those chunks straight to the LLM, we add an intelligent re-ranking step. It's like telling your search engine, hey, don't just give me the first thing you find, give me the good stuff. This stage prioritizes the most promising, most semantically rich, and most query relevant context pieces. We're no longer settling for top n by cosine similarity. We are curating a short list of contenders. Now, the agent steps in for the first time, and this is a very first major role, evaluating the quality of the retrieved context. At this point, the agent is basically acting like a skeptical editor who asks, are these chunks truly relevant to the user's question, or are they just loosely related? Are they complete, or do they leave out key details that are essential to lead to a good answer? Do they fit together cohesively, or are they disjointed, fragmented, or even contradictory? This evaluation takes us beyond surface level scoring. It moves us into semantic usefulness. It's not really about how close the chunks are in the embedding space, but how helpful they are for generating a trustworthy answer. Once this context has been cleaned, validated, then we pass it along with the original query to the LLM for the generation. But here's the twist. We don't just take the LLM's response at face value. We bring the agent back for a second round. Now it's time to evaluate the output itself. The agent scores the response on several critical dimensions. Hallucination detection, which checks if the answer is actually grounded in the retrieved context. Faithfulness, which checks if the output stays true to the original source material. Calibrated confidence, which checks how likely is this answer to be reliable given the quality of the context and model's own uncertainty. Fact checking, which checks if the key claims in the answer hold up under scrutiny. And here's the final step, and maybe the most important. Instead of returning a black box answer to the user, we surface transparency. The agent provides trust signals. It highlights how much of the response can be trusted, why it thinks that, and even which specific context chunks support which part of the answer. Now, this is complete opposite of the guess and hope it works method that we are used to for large language models. To wrap this up, this approach doesn't just make the LLM smarter, it makes the whole system more intelligent and, more importantly, more trustworthy. We are giving the users three powerful things that are sorely missing in the traditional RAG systems today: visibility into what the system is doing, context awareness at every step of the process, and confidence in the final answer. This is a path towards not just better responses, but towards more responsible, reliable, and human centric generative AI. Now, let's look at what this actually looks like in practice: a transparent RAG system at work. Here's a sample question: what were the major policy changes in the 2024 US budget for small businesses? Now, traditionally, a RAG system would retrieve context and generate an answer, and that's it. The user has no visibility into what parts of the answer are trustworthy or where the information came from. But in our approach, it's different. The system performs a few key steps. It starts by searching the database for relevant context. It then performs context evaluation to ensure what gets passed to the LLM is actually useful. After then, the LLM generates a response. Now, here's where it gets really interesting. Instead of handing the output to the user as it is, we bring in our evaluation agent here, and it breaks down the response segment by segment. Now, here's what it found. The claim about the new tax credit for hiring apprentices is marked with a green and a confidence score of 92%, which means that the agent is strongly supporting in the retrieved context for this specific fact. The statement about SBA backed loans funding is flagged with an exclamation mark with 65% confidence, which means that it's partially supported. Maybe the number is unclear or the context is vague. And the line about a temporary corporate tax reduction is marked with a red cross with only 42% confidence, which means that the agent feels that it's likely hallucinated or unsupported by the context. We then surface this evaluation in a clear, structured format, as you can see in the table here, breaking the response down into the specific segment of the answer, the confidence score, and whether it passed fact checking. This makes the entire process transparent and trustworthy. Instead of a black box output, the user sees not just the answer, but also why should or shouldn't they trust different pieces of the answer. Now let's take a step back and look at the big picture. Why does this new approach help us? What are we actually getting out of this? Why should we even implement this new approach? Now, at the core, it delivers three major advantages: trust, transparency, and accuracy. The first one is trust. Users today are increasingly skeptical of AI generated content, and rightly so. By using this approach, by showing them what parts of a response are backed by real context and which parts are shaky or unsupported, we are building trust through honesty. Even when the confidence is low, we are not hiding it, we are surfacing it. And that itself boosts trust. We are providing clear demarcation of what we feel, the confidence of what parts of the response, which helps the user in making a decision of how much it actually wants to trust what part of the response. The user can also see how the response over time and the confidence score is actually improving as the agent keeps on getting smarter and understands more perspective of the user. The second one is transparency. Now, traditional RAG is a black box. You ask a question, you get an answer, and you're left guessing on how it was generated. In contrast, this approach makes the process visible and explainable. You see what was retrieved, you see how it was evaluated, and you see where each part of the response came from or did not. This is AI you can reason about. The third one is accuracy. By improving the context quality before generation and auditing the response after, we significantly reduce hallucinations. This isn't just reactive, it's proactive quality control. And because we evaluate both the data and the response, we catch more issues and surface more insights than LLM only evaluation ever could. This is more than just a fix for hallucination. It's a step forward towards responsible generative AI, one where the users aren't just told the answer, but they're also empowered to understand and trust it. They can see the response, they can see different sections of the response, and then make an informed decision as to what exactly they need to trust and what parts of the answer they should go forward. This will improve the relationship between the users and the AI and will be a step forward towards responsible AI. Thank you everyone for your time.